Welcome to our first meeting for SMPTE this year. I hope that you've had a very good start to the new year. Just a note that this meeting is being recorded and it'll be posted later for you to review or to share with others. All right. So we have cloud-based live production with Mike Cronk, which I'm very excited about. It's clearly attracted a big crowd. First, I want to introduce our Sacramento SMPTE board. So I'm the chair, Remington Maxwell. We have our past chair, Dom Jackson, our secretary and treasurer, Mona Smothers, and our managers, Sean Case, Bob Huddleston, Patty Leonard, Gil Mazzi, Paul Turner, and Tim Walker. Just a little pitch. They do have, SMPTE has discounted virtual courses. We have a promo code 25 off, so you could get 25% off. I was kind of checking it out earlier. There's some stuff on HDR, some of the new standards. With all this time at home, it might be a good opportunity to learn a little bit more. So I encourage you to go and check that out at SMPTE.org. If you are having any financial difficulties with becoming a member, we want everyone to become a member. It allows us to sponsor events, to eventually go back to in-person events where we would have our snacks and our beverages. And you also get a lot of benefits like the SMPTE magazine that comes out. So you can email Roberta Gorman at rgorman@smpt.org for more information. Here is the membership pricing. So professional, 165, executive, student, recent grad, which I didn't know about. I could have used that a couple of years ago, retired, and fan. So everyone's already muted. You're doing a great job about that. So I just want to mention that if you do have a question, Mike said that you could feel free to come off of mute and ask him, have more of an interactive session. Otherwise, you can ask a question in the chat box and then it can be answered at the end. So tonight's presenter, Mike Cronk, is Vice President of Advanced Technology for Grass Valley. Michael guides the critical development of Grass Valley's next generation core technologies for both cloud and on-premise topologies, including Grass Valley's innovative new Agile Media Processing Platform, AMP. Michael serves as chairman of the board for the Alliance for IP Media Solutions, AIMS, an organization dedicated to the promotion of open standards and specifications for the media and entertainment industry. Michael has held a number of leadership roles within Grass Valley, including General Manager of Server and News and Vice President of Marketing between 1989 and 2008, Senior Vice President of Marketing and Products in 2013, and Senior Vice President of Strategic Marketing from 2014 to 2016. Mike holds Bachelor and Master of Science degrees in Electrical Engineering from MIT. And we're so happy to have you here, and take it away.
Thank you, Remington. Let me, you'll stop sharing and I will share. Let me know if you can see my screen.
Yes, I can.
Okay, great. It's great to be with you. There's so many names on the participant list that I recognize and have either worked with or worked, in the industry with. So it's great to be with you. I'm live in the country outside of Portland, Oregon, having internet problems today, and so I'm on a 4G hotspot. So apologies if I see all the videos frozen or something like that. I'll know I need to stop and figure that out. So hopefully that won't happen, but it could. So the topic that I wanted to address today is talk about cloud-based live production. It's really kind of a presentation in three sections. There's the kind of why is that important? What's the kind of the business need behind that? And then doing live production in the cloud, with that there comes a lot of technical obstacles. So what are those obstacles to doing cloud-based live production? How can they be addressed? And then the latter third of it is really taking a couple of use cases and kind of explaining what we've been able to do in 2020 and how we progressed that through the year. And then just at the end, a little bit outlook on, remaining challenges, things for the future. So that's the agenda. As Remington said, if you have a question, feel free to interject and ask. I don't think this will, take the full time, so there'll be time at the end also for questions. So with no further ado, let's dive in. So just in terms of the kind of the business imperative for cloud, I wanted to kind of just give an illustration and step back and look at, how has broadcast changed over time. And really it's about content creation and delivering content to consumers of that content, viewers. And so this is kind of an analogy where a star is a piece of content, right? So we've got two pieces of content, and they need to be consumed by viewers. And so the traditional way we did that is we had channels. I'm old enough to remember the 13 channel VHF plus the UHF. We had to actually get up off the sofa to change the channel, and so we did that. Content creation has actually grown quite a bit since those days, and just even the last 10 years, it's estimates are anywhere between 2 to 4x the amount of content is being created. And so conservatively, let's say that there's twice as much content, so we got twice as many stars. So those get distributed to, we're proliferating channels as well. But viewership is, basically people are viewing about 50% more content than they used to. So that was kind of the thing. And there's this kind of linear increasing model. And then with web technologies and personal devices, phones and tablets, this whole picture exploded. So now there are multiple ways to distribute content. As an example, Premier League soccer, there's a contract with, say, Sky in the UK or the BBC, but there's actually 30 outlets for distribution of just that one piece of content. And so the distribution channels have proliferated. And so that's created a challenge for broadcasters. Content's growing at 2x, viewers 50% up, but the number of channels that you have to distribute to is going through the roof. And so what does that mean from a business perspective? Well, first of all, the fundamental thing is that if you look at that, go back, that the yield per asset per distribution channel, if you will, is going down, right? So content is growing, viewership is growing, but the yield per asset's growing. So from a business perspective, from a revenue perspective, what does that mean? Well, our broadcasters need to get more out of their current assets, or they need to generate new revenue streams, generate more assets, if you will, that can be viewed and generate revenue. From a cost perspective, then it also means that, cost structures have to be aligned with that revenue. If the revenue per asset is going down, the cost structure to produce that asset, distribute it, that has to go down as well. And yet content creation costs are going up. You think of the rights fees, for example. So that there's a struggle there from the broadcaster's perspective. And so it's driving the need to be more efficient at the other aspects of cost, namely a lot of what, broadcast equipment suppliers provide. So that's creating a challenge. And some of these key challenges are, if I'm going to generate new revenue, I want to be able to do that quickly. So if you think about the SD to HD transition and how long that took and how much capital that took, and a lot of us, I've known you for a long time, have been during that phase in the late 90s to 2000s where that HD transition was going on. Though if somebody was upgrading their plant, that was a 2 to 3 year project a lot of times. With a big capital equipment. So if I just want to experiment, say, is this a good revenue idea? Can I make this, distribute this content? Can I make money doing that? That's a fairly inflexible way to go about it. Another challenge is that as we try and build systems together, especially with new technology and software, it's getting harder and harder to integrate. And we see this with a phenomenon, even with 2110, there's more to it. And there's a lot, and therefore there's been a lot of effort in SMPTE, with 2110, in organizations like AIMS to try and foster that strong integration. So those are important efforts. It's still harder as we kind of go to more networking and software-based things. So these are challenges that the broadcasters face. And with that as a background, you look at cloud and you think about, well, cloud is something where it's extremely agile, right? I can spin it up, spin it down. I can pay as I go. And so it can help address the first of these challenges, right? That it's hard and it's inflexible and static. I can do something very flexibly. If it doesn't work out from a revenue standpoint, I don't have to pay for it anymore. But there is, software integration things as well. And there's also a dynamic where if you look at how cloud compute or elastic compute has been adopted, it's being adopted at different rates or at different places in the adoption curve, depending on the application. So OTT, streaming, VOD, all of that really is in the cloud. That's mainstream, right? Every streaming service that we have, be it Hulu, Netflix, anything from CBS or Disney Plus, that's all already fully in the cloud. If we look at the standard workflows, the more traditional workflows that are broadcast, linear playout as an example, there are a number of companies now with kind of cloud-based linear playout, but it's still early in the adoption phase. Most people have that in their current fixed facilities. And live production, especially if we look back to last year, really nothing's happening. And so that begs the question, if elastic compute is so good and can help us with business challenges and make us more efficient in things like OTT streaming, why is it, what's hard about it in terms of live production? Because that's where the hardest challenges are. And so looking at that, there's 5 areas that we look at and say, okay, these are hard, right? So first off is latency. It's great when you're in a facility and the equipment room's next to the control room, and speed of light over those distances, your electrical signals, we're timing things to lines, right? So it's very easy, low latency, no delay, and talk to the announcers if you're in the OB van that's right next to the stadium, as an example. But if I have to go to a cloud instance that's 500 miles, 1,000, 3,000, 4,000, 5,000 miles away, now the speed of light through fiber really matters, and it's can be in hundreds of milliseconds. There's processing delay, and pretty soon it's like being on a Zoom call where somebody has got a speaker next to the microphone and the echo canceling isn't working and you can't hear it. It drives people nuts, right? So latency is a big thing to solve, and there's a physics problem there. It's not, you can't just change physics. I/O scaling, if you think about live production, that's where you've got multiple cameras all coming in with multiple positions, and people have to operate in that. And so the scale of the amount of inputs and outputs that you need in a live production really is at a different level than what you need for a playout channel, as an example, or an OTT channel. In terms of playing out the content, obviously in the OTT, there's the whole CDN network to get to the consumer, but that's been solved. So I/O scaling for production with 1080p and UHD type of signals is hard. So that's another obstacle. The third one, and it could be overlooked, but if you think about how transitions go in the broadcast industry, this is a very important one, and that is integration with on-premise operations. What do I mean by that? Well, nobody's just going to say, throw away everything that we've got to invest in our physical plant, and we're just completely going to go to the cloud tomorrow. I mean, that doesn't happen, certainly not in our industry. There's an ongoing operation. There's equipment that can be leveraged for a long, long time. So if I'm going to do something in the cloud, how does it integrate with the things that I already have? And that needs to be solved. And then probably, actually, one of the most important ones, not necessarily technical, but technology can be applied to it, is what is the business model? I mean, it may sound good, and there's a lot of industries that have transformed themselves from maybe a bricks and mortar to a cloud type of thing. But does that work for broadcast? And is it, if I put it on a spreadsheet and I look at the ROI, am I actually going to be more efficient economically if I do it in the cloud? And that takes some work and figuring out and solving. And then the last part, the last one is functional sufficiency. And this has to do with providing the tools that allow people to do their jobs. And you think about live production, it is a creative process, right? That the TD and director know what they're doing, but they also know what cameras to call. They know how to put a show together. The graphics operator has their tools. Replay has their tools. Even the engineering staff has tools that allow them to make sure that the level of reliability that they need are there. And so, to make it really work, you need all those functions fully supported. And so looking at that and going back a slide, why is live production where it's at? Well, it's due to reasons like this. So the challenge and the technology focus we've tried to put together is solving these problems, right? Let's swing for the fences. Playout's good, but if you can solve for live production in the cloud, you really in broadcast can solve for anything in the cloud that we need to do. And so that's why tackling these becomes important. And so we've done a lot of work to figure this out, put things together. And so I want to speak to how are we making progress in these 5 areas. So the first one is, how do we address latency? It's with what we're calling intelligent timing management. Well, that's a catch-all phrase for a number of things that are breakthrough. First of all, source time alignment. It's, if you're in the same plant and you're traveling over coax and you got SDI, it's pretty easy to line that thing. But if you're sending signals across the public internet with different hops and all that kind of stuff, signals can arrive at different times. It's very hard to cut a show between cameras if your sources aren't aligned. So technology that allows you, from timing technology and timestamp technology and receiver technology, that allows you to align things so that everything that a TD sees in a multi-viewer is aligned. Another key aspect of intelligent timing management is to provide low latency, high quality video and audio monitoring back to the talent, the production crew. And this, we've done a number of situations this year, even on some larger broadcasts with some networks, where you can't put as many people in the truck now because of COVID. You got to have spacing. Assistant producers, those people need to be at home and still call a show and be on intercom. So how do you do that? And so developing low latency, high quality monitoring that doesn't break the bank in terms of bandwidth and in terms of expensive decoders and things like that is important. Another aspect of intelligent time management is low latency control. As a TD, I'm pushing buttons on a switcher. I press the button, I see. So if I take a camera to program, I want to see it, and that interaction has to be there. There can't really be a lag. So working with the control message, that would go from somebody's home, or if they're in a control room, the control room, up to the cloud and back, and making sure that feedback mechanism for the operators, for the crew, can be there is a key aspect to work on in terms of intelligent timing management. And then there's the system level timing management, which is, I've got multiple sources, things going on. There's different timing planes. How do I time those in a smart way, in an automated way, such that I can put the broadcast on, and the production crew and the people doing the broadcast, it feels like I'm in a control room with the sources right next to me. And so got a picture of Albert here, very respected, speed of light through fiber equals MC squared, all those good. We can't change that stuff, but with an understanding of what operators need, we can manage it in a way that allows people to carry production in the cloud. And so that's a key aspect of breaking through and doing live production in the cloud. The other key thing, or one of the key things, is addressing I/O scale. And there's kind of three ways to do that. One is, well, so first of all, in the cloud, you're running essentially on a virtual machine. So there's compute hardware underneath it, but it's general purpose compute. Could have a GPU, does have a CPU. That needs to, in order to get more channels on there, if you think about it, so I've got inputs and outputs, and a lot of times I'm encoding and decoding, so that takes compute. I'm doing, if I'm doing a switcher in the cloud, I've got mixed effects. I'm writing different channels to disk for replay. So one of the things, if my compute is fixed, I can optimize my software to run more efficiently so that I can get more channels. Ergo, I can scale. So that's the first bullet of. The second one is really from a broadcast, equipment supplier like a Grass Valley. This is one we get from the cloud vendors and kind of right away, but scale up. What does that mean? That means making the compute instances bigger, more powerful effectively. So AWS, Azure, Google, they're coming out with newer instances with faster CPUs and GPUs or more cores and different technology that allows us to just kind of ride that wave and over time do more. The third one's very, very interesting, which is scaling out. And so the difference, scale up is buying a bigger computer. Scaling out is using maybe a smaller computer, but more of them horizontally and having enough interconnect between them such that my I/O can scale. And so that's a very key aspect. And those are kind of the three philosophical ways they can do it. And I can say that what's important is really to work on all of them, because they're all progressing in different rates, and there's different needs out there. So just put a graph on this to kind of share where we are at the end of 2020. We didn't start here. The first shows we did were, the equivalent of 4-camera and 8-camera type of shows, but we've done 20 plus as of December through working on these three axes, or these three kind of levers, if you will. From a production complex, there's so many aspects of production complexity, but this a proxy for that would be how many MEs can I do in a switcher, for example. And as you'll see, we've gotten to a fairly high degree of production complexity in that axis. So those are the things to think about in terms of addressing I/O scale. What about integrating with on-premise operations? So you've got a traditional control. How do I link with that so that I can have maybe part of my production is done on-premise, part of it's done in the cloud? Well, one key aspect is transport integration. So because you're going to the cloud, you typically have to transmit over WAN, and you've got different types of compression going on. And so that's a given here. But once I get into the facility, I need to provide those signals easily as SDI 2110, and in some environments, even NDI. I need a way to connect the signals that are arriving. Excuse me, get a drink of water here. Connect that to a modern routing system. So if it's a 2110 or IP-based routing, then NMOS, ISO4, and ISO5 support. Excuse me. And then with monitoring, want to be able to, in this control, I need to be able to see the pictures of what's going on in the cloud and vice versa. And so solving that. And then key to any production is intercom. Trying to do that without any intercom would be impossible. And so a good, solid, low latency intercom that extends to whatever the cloud production is important as well. Of course, I haven't had a frog in my throat all day, but now it happens. So then what about addressing the business model? And again, this is probably one of the as an engineer by training, this is kind of one of the trickiest ones. There's human factors, a whole bunch of things, but first of all, what we've learned so far is the model needs to be flexible. So this is a SaaS offering. And so that in SaaS, there's different models. There's, pay as you go. Well, pay as you go is typically tracking usage by the hour. Customer gets a bill for how many hours they used of certain things at a certain cost. So another model is a subscription model where it's still software as a service, but I sign up for a month or a year and I pay a flat fee for that. And then I can kind of use all I can eat, if you will. And what we're finding is that different customers have different models, and we need a model that allows for either of those, right? Another aspect of it is working with customers and thinking through, if you're going to do an R&D development, looking at total cost of ownership, right? Because it's not just a comparison between, I've got this switcher that's hardware and I got this switcher that's virtual, and do a cost comparison there. It's, well, if the virtual one, if I don't have to ship the switcher over here and the TD doesn't have to travel and all these kind of things, those are cost, and what my telco cost is, which can be a kind of a headwind in terms of a cloud environment, because there's probably doing more telco. Look at that holistically, and does it pencil out, and can we work with broadcasters to figure that out? And then I think the last aspect is driving efficiency. And while the first two are really kind of, I would say, kind of client or customer, broadcaster facing, driving efficiency is primarily kind of internal facing to one's own company, right? So how do I support, deploy, do this as efficiently as possible? What tools do I use to work with customer? How do I use technologies such as infrastructure as code so that I'm not spending time debugging what the underlying infrastructure is doing, right? Because this is highly complex, and you need tools that make it easy for yourself and the customer. And that then also translate into a better ROI, both for you from a cost perspective, also for the customer in terms of their service and their costs, because they're not, debugging and troubleshooting as much. So those are real key aspects of addressing the business model. In terms of addressing functional sufficiency, it's really, as I mentioned before, it's getting in a regular live production. You got production switching, you got audio, you got graphics, you got replay, you got camera shading, you got probing and monitoring, so you can keep the system, on the air and know what's going on. And so all those things have to be there. One example of that that I'll share here is, in terms of getting professional tools, is an example of what we've just done here recently. Really, we think at Industry First, where you've got a TD, actually in the Sacramento area, sitting there. That's in front of a Corona panel, so a Grass Valley Corona panel. Typically, a Grass Valley switcher is a Cayenne Carrera Corona panel, and then you've got a frame of so many RU, depending on the frame, behind that, in equipment room next door, and that can be remoted as well. In this case, there is no frame. What there is virtual K-frame software running in AWS. In this case, it was running in an AWS data center called US East, which is in Northern Virginia. So roughly, call it 3,000 miles away from Sacramento. TD is sitting there with his low latency monitoring on comms. In this case, he's the TD and director cutting the show. The actual event was happening in Europe. And he had over 20 contribution sources, both talent and gameplay, coming into AWS and calling that show. This is an example of functional sufficiency in that TD, Jeff, has cut. He's worked on on K-frame switchers for National League Championship Series in baseball, and he's worked on Super Bowls, and he's worked on these big live production events. As he's punching the button, it's the same thing for. He's got the tool that he needs, and that's the level of functionality that we want to strive for in every axis of this product list. Not that we're there yet, but that's the example of trying to push the envelope as to providing tools that people can understand and do exactly what they're doing. It just happens to be virtual. Another example of functional sufficiency is making a UI set that works for every user. And what do I mean by that? So one way to get to the cloud is to take an executable, just a program, do what you call lift and shift. So to load that in a VM in the cloud. There's technologies such as Teradici where you can bring the UI back to you, and somebody just operates that single application in the cloud, which is fantastic. It's a great way to do things for many applications. When you think about live production and the multiple operator stations, that becomes hard if the audio operator and the TD and the replay operator need to operate on the same interface. It's very hard because there's one of them. You can't really do that. And so having a Microsoft service-based approach where you can have interfaces, in this case, there's a switcher it's an HTML5 interface, but it's a switcher in the bottom right corner. There's a couple multi-viewers laid out, and this person was both kind of an engineer and a TD for that project. He's got a dashboard and another third-party tool for graphics in the upper right corner called Singular Live. That could be for the TD / kind of engineer for the show. If there's somebody rolling a bunch of clip players, a tape op, they can have an interface that's just for them. If it's the graphics operator, they can have an interface that's just for them. Just like you do when you build a control room today, physical control, and there's a different seat and there's different controls in front of each operator that gives them the tools that they need. We need a way to create that as an example. Another aspect of functional sufficiency is the probing and monitoring. So having tools for system monitoring and visualization. So this is an example of, I believe it's EA Sports, I think, that with a dashboard that's showing all the various microservices, inputs, outputs, switching, mixing, audio mixing, and you have to zoom in on that, but up at the top, there's these gauges on how much CPU and GPU I'm using. They're color coded. If there's an alarm, it raises, and you see what connections and what's flowing where, so that at a glance you can see and understand what's going on in the system. Then dive into probe. So all these interfaces need to be there. What I want to do now is just kind of illustrate some of this technology with a use case, which is esports, and I'm kind of picking from two different customers there. One is Blizzard Entertainment, which is our launch customer, which our first event with them was doing live master control switching in February last year, then progressed into more kind of distributed rope production for the actual show when trucks couldn't roll to their venues, and then EA Sports, which we've been working with very closely, especially in the latter half of the year, and to illustrate, what were they looking for, how did this solve the problems, and then kind of how did the technology and the challenges we're faced, how do we progress those across the year? Because this is an early stage thing, cloud-based live production, so there's a lot of work to do, not only for Grass Valley, but for multiple companies and building an ecosystem. But these two use cases give a little bit of a window into what can be done today and how have things progressed this year. So the first customer, Activision Blizzard, there's three shows that we worked closely with across 2020. Overwatch League, Call of Duty, World of Warcraft. My son is familiar with all these, and he can kick my rear end on every single one of them, no doubt. And then EA, the two main properties been working with are Apex and FIFA 21. And so all of these shows do broadcasts. Sometimes they're carried on over-the-air channels, often YouTube, Twitch, those types of things with quite a big fan base. And so Blizzard Entertainment, where did we start with that? Well, their need, and we began working with them before COVID, so these needs are kind of transcendent of anything that COVID drove. They needed a flexible, agile way to enable true home and away format. So they have, I can't remember the exact number off the top of my head, 16 to 20 teams in different divisions, kind of like, a Major League Baseball or National Hockey, but these are professional athletes that have a team. They get paid to do what they do. And in 2020, for the first time, instead of having them all live in LA and go to one studio to produce the games, they said, well, the Shanghai team's going to travel to Dallas for a match, and the Paris team's going to travel to Korea for a match, and the Berlin team's going to go to Montreal, and literally worldwide home and away, just like home and away for baseball. And they need an agile way to do that. So that was their need. They also had the need to. They've got a lot of properties that I didn't show, Diablo, some other things like Hearthstone or games that they own, where they wanted to better monetize them, but they needed to experiment. And so they wanted to be able to experiment while not having a significant broadcast revenue stream. Back to that whole thing about if it's an inflexible CapEx, that's very hard to do. And then specifically for them, because especially with Overwatch League, they actually had sponsorship deals that were regional. They needed a way to do regional shows, kind of the output, the master control need to handle regional branding, commercials, graphics, and audio that was different for the audiences in, I think it was French, Korean, English, and Chinese. And then for Apex, just so you kind of get a flavor, there's some similarities. So we engaged with Apex after COVID, and so one of their highest need was, I need a completely distributed remote production workflow where literally everybody can work from home. We can't go into the building anymore. So that kind of was a key thing. That actually became a need with Blizzard as well as we went into March of last year. They also, very important to them was production quality storytelling. They were used to going into a studio and producing with broadcast equipment. So they didn't want to sacrifice on that. Geographical pivotal scalability. So again, like Blizzard going around the world, they didn't have arenas and teams but they had individual players that were all over the world. So they would do a European event one week, then they're going to be doing a Latin America event another week, and an Asian event another week. And so where they spin things up, they didn't want to have to send equipment on boats and trucks or do the logistics of hiring that locally. So they want to be able to just put that in AWS and go. And then to them, very important was extensive probing and monitoring capabilities. They had tried some early, kind of forays in the cloud and recognized that was key, as it is in most professional broadcasts, especially with IP. And so here's an example of how Blizzard did this. This is from kind of second quarter last year and on. Started out first we started out doing master control, and that's where we started in February. That's kind of grayed out here to show the production. But then as COVID hit, nobody could go to arenas, and so now they needed to recreate that production experience. And so they started out. This is all on AWS, but each of these boxes at the top represent an EC2 instance in AWS, so a compute instance, and they spun up multiple ones. And so PCR2 was essentially a sub switch of the game. So the game cameras, in the case of esports, those are virtual. So it's somebody flying around in a workstation in 3D space. They're the camera person, if you will. So they start out and they had 4 observers. So it's like 4 cameras into that, do a sub switch of that. They also had what they call casters, which is the talent, the play-by-play announcers. And they were going to be in 2 different, they're in their homes too. So everybody's in their homes here. They had 2 of those, put them in a 2-box, integrate that into the kind of the program out, which was done at PCR1. And then their event would go all day long, and they had, in the beginning and halftime and in between shows, they'd have an analyst show, kind of like in the NFL when you go back to the studio and hear, Boomer Esiason or whoever's talking about football. same type of deal. And so they had a separate control room, if you will, virtual control room for that. All of those two fed into master control, and that was redundant. There was a replay feed by vMix, and then the operational crew was dispersed across. They were also in their home. So contribution had to be to the cloud, but everything other than that was in the cloud. Control, monitoring, intercom was done. Had to be there, and so that's where they started. To give you a feel that this is what the studio looked like. It's different shots of people's home with computers, some interfaces. This was predominantly, certainly from the Grass Valley perspective, a kind of HTML5 based point the mouse and click or use a touchscreen type of production. And then by October, so Apex came in, their first event they did with us after kind of an evaluation of many technologies was some events in their autumn circuit in October. And so they had now 8 virtual cameras, 8 contribution links for talent. So they had more talent that they were weaving in and out. And so the size production in terms of camera began to grow. Still live switching graphics, audio clip playback. And depending on which show was contribution from multiple different regions, all again, 100% cloud-based, everybody at home. And then recently with eSports and FIFA, we continue to push the envelope. So how do we push the envelope here? Well, we got to that 20 plus sources. I can't remember if it's 22, 24, or 25, but it's in that range in terms of number of sources coming in to a TD, and that's not counting clip players and RAM stores and other graphics. Those aren't counting in that source count. Those are in addition, so that's all there. But one of the key things is we went from basically through the year using a master control switcher and tweaking it to figure out how to do 2 boxes and 3 boxes and pull off some level of production to everything in that K-frame panel that all the 2D DPMs, EMIMs, macros, that just works. And it's the same feel when they're doing it. So again, upping the production value. So this is just kind of illustrate with some esports examples how the technology has been used, why they're using it, and hopefully to illustrate that there's a progression and a continuum. Because I think one of the key things about this is we're not done. From a 2020 perspective, though, there's quite a few things that in terms of breaking down those barriers and those obstacles that I mentioned. We have been able to do fully elastic, globally pivotable production. That's what you see. Everybody's in their home. They literally, before they come in the morning before the show, they turn it on. Before that, all those AWS EC2 instances are dormant. Nothing's happening. With a push of a button, all that stuff spins up. And within a few minutes, the monitor wall starts lighting up and they're ready to go. And when the show's done, they turn it down and the meter stops running. And so for somebody who has very elastic and spiky production needs, provides a fantastic way to do that. And because they have a global audience and global locations for production, the fact that if I want to do it in AWS US East one week and I want to do it in EU West in Ireland or EU Central in Frankfurt, I can do that at the push of a button. Getting to ultimate, I say ultimate in the sense of it's ultimately distributed. Literally everybody's at their home. I don't know how more distributed it could be. And literally the production staff has said, there are some limitations in esports gameplay where the players have to be, within a 5 millisecond ping time. Otherwise it's hard to do the game. But from a production perspective, crews can literally be scattered across the world. And in fact, in some of the monitoring that we've done for major sporting events in the US with the networks, there are operators in the US, all over the US, but then there's been graphic operators looking at monitoring from the system that are in New Zealand. And so I think we've checked off a significant list of functionality. I wouldn't call it functionally sufficient for every production, but having a top of the line broadcast switcher type of functionality and being able to go up to 20 cameras, I think is a tremendous accomplishment, going from kind of, obviously the R&D for this has been long standing, but from a market perspective, going from basically zero to that in a year is pretty great. And we think we can push the envelope a lot further as we go forward. But there are a lot, as I stated, a lot of areas to improve. So got to keep working on scalability. There's a lot of shows that are way above 20 cameras, especially when you consider like pylon cams and gold cams and all those kind of things. The camera count goes way up. More tools, better tools for replay and audio mixing are two areas that I think are needed to bring in and be able to cover more of the live production space. Broader ecosystem, and this is important. Those of you who know me from AIMS know there's a real advantage in working together across the industry on how we integrate in things, and I think that's a key theme for this is building out that ecosystem. And I think this last one is going beyond the 20 camera show is what I mean. That's kind of redundant from the scalability. So that's an edit mistake probably, but those are some areas to improve. So, what are the conclusions from this? I think cloud production, first of all, it's not on this slide, but it's not for everybody right away. Obviously there's a lot of very good workflows that are here today. So I'm not here to say, oh, it's all going to the cloud next year. But there's some very, very real and tangible advantages and savings in efficiencies that can be gained depending on where one is. And so I think cloud, this was a breakthrough year in that aspect, because now there's a tool set that people can start to experiment with. I think we've proved that the fundamental challenges to doing live production in the cloud have been solved. It's now we've got to keep on working to prove that out at bigger scales with more levels of functionality. We're still at the beginning of an adoption curve. There's no question. This is very, very early. And so there's much to do to address a wider range of use cases. And again, I'm not saying that everything's going to the cloud, but if there are differences between our industry and other industries, right? But if you look at publishing with books or the music industry or radio, or there are advantages economically and for consumers of cloud, and those are real, and harnessing that and figuring out how to bring that to our collective industry base helps the industry migrate into where it needs to be. And so and it becomes then a tool then, and people say, okay, there's a CapEx model that's going to work for me. Maybe I get 24/7. I can use that a long time. That's not going to change. Awesome. But what about peak loads? If I can spin up in the cloud and that's easy and that's well integrated, then that's a tool set that I can use. So like any of the things that we've encountered in broadcast, this is a transition that takes time. But I think there's been significant breakthroughs and fundamental technology proof points that are going to serve us well. And I'm very excited about the future of our industry and what we can do together in this important area. So I think that's it. I don't even have a thank you slide, but I do thank you for listening to me for this long. So are there any questions?
Awesome. Thank you. Let's see, any questions? If you do have a question, you can just come off of mute.
Hi, it's Patty. How is audio latency working? That's just always such a big problem.
Yeah. So I think audio latency audio is the most challenging one from a latency perspective because just it's human factors, right? So we, humans can see a difference in two, videos arriving if it's like over like 100 milliseconds or between 60 to 100 milliseconds, people are going to notice that. If audio is different from 5 milliseconds, right? So it's a lot tighter human factors requirement. And so there's, essentially you need to figure out how to use low latency audio techniques, especially for comms and when you're doing interviews and things like that. Zoom, we're all using Zoom right now, and we can carry on a conversation. And typically I don't step on you or I don't step on Remington. We can have an interactive dialogue. So there are technologies that allow over quite a bit of distance people to talk to each other, right? And so it's it really involves how do you employ that? And then overall, there is another issue with audio latency or timing, which is I cut a show and I've got program video and then, A1's usually sitting on a different mixer. They got program audio. That has to be married up in sync, and you need to address lip sync. That could be happening. Essentially, that program audio could be delayed from real time by more than the delay that we're having on Zoom, but it still needs to be in time, right? So that when the audience sees it, it's not jarring and they don't notice the lip sync. So, but audio is the challenge. But the fact that we're talking here on Zoom and can have a normal conversation is a technological proof point that low latency audio conversation can happen.
David had a question. What were some of the biggest challenges in creating a video switcher to run in a cloud instance?
Oh, I want to just kind of tip my hat to some Grass Valley, California, not just Grass Valley engineers from our switcher team. They're on this call that I think it took a lot of creativity and ingenuity to take something that is literally all FPGA based and come up with the concept of what we could do, and then marrying it with some of the things that we're doing in cloud. So that I think just getting to the right architecture and figuring that out and talking through was a big step. And then another challenge is that the kind of dev stack, the software technical staff for cloud versus maybe what we do on a more traditional product is quite a bit different. So there's a learning curve, right? So merging those two learning curves was a challenge, and so those are at a high level. I would say that those are some of the things. But I think that one of the big things is I need to be able to route my control over the internet. I need to be able to push a button, and things need to happen at the right time. And so there's a lot of work in technically to sort all that out and make all it happen. So my hats off to the people like Dan and Nick on this call and the engineering team that are making that happen. But I think that I guess one of the lessons there is if you go back 4 years ago, Grass Valley had done a cloud product here and there, but we weren't a cloud company by any stretch of the imagination. But we did have some people that we said, okay, let's go learn this, let's understand. But then I think it's really, and this is for you're in the this group, a lot of them are in the Grass Valley area. There's a whole host of company, AJA, others that are in that area. The knowledge of what to do with video was just as important as the cloud piece, right? And so I think there's a lot of opportunity for people to learn, embrace the cloud technology, and figure out how do I apply my knowledge of video to it.
Do you think that we're going to have a bunch of new standards specifically revolving around cloud-based technology with transportation of video and audio?
Yeah, I think we will. I think that a lot of the standards are already there. And you know, in some cases, yes, in some cases, no. So what do I mean by that? So there are a lot of, you know, IETF standards, RFCs, about how to, you know, transport encoded information over RTP.
Mm-hmm.
You know, SRT is an ARQ protocol that allows you to kind of essentially do like a packet retry if you, because that's one thing about transmitting video over the internet, you're going to have packet loss, and so that's open, and so there's a bunch of things where the IT industry, some industry has built those standards. I think there are more to come. And it's kind of in a formative time for that, pretty early time, because, you know, honestly, there's a lot still being figured out, but I think it will come.
Do you think that the adoption of just using live production in the cloud has been accelerated because of COVID?
I would say absolutely.
Well, I think he was saying absolutely. I'll just wait a little bit.
I think accelerated that transition, and it's kind of slayed a few sacred cows about how things have to be done, right? Because production, as those of you who work with, you know, high-end production crews on our products, you know, there's like, this is the way it needs to be done. I've done this for 15 years. I'm the professional. All of a sudden, it's like, I'm not going to work unless I use this tool over here. It's like, okay, you know, I'll try that, and gee, it's not that bad, and then you get used to it, right? So that dynamic has certainly happened, but there's, even with COVID, there's still a, you know, an on-ramp and a transition that needs to happen.
David had another question. Will 5G build out help address some of the latency issues?
Yeah, it's a great question. I think it could, but that really depends on essentially what's happening at the kind of local point of presence is that, you know, in the telcos that are aggregating that 5G. Because if there's, you know, compute hardware there, then you can run things like AMP on that hardware. And now I'm really close to the stadium, right? Because the one thing that cloud production doesn't solve, if I'm 1,000 miles away and I've got a round trip, you know, distance of 2,000 miles, that program out will be delayed versus, you know, live what you're seeing to a noticeable level, so that that feedback loop of that video. If I were sitting, if the audience in the stadium looked at the output of that program out when it got back to the stadium on the scoreboard, you know, the touchdown would happen, and then, you know, 1, 2, 3, touchdown. You know, there'd be a little bit, there'd be enough of a lag there that, you know, people would kind of maybe pick it up. Now that doesn't, in most cases where you don't have a feedback loop, that doesn't matter, right? So I you know, a number of years ago, went to New York Monday Night Football game in New York Giants versus Minnesota. There it was in New Jersey. Called my wife in Oregon during the game and said, you know, Minnesota scored a touchdown. And then she's watching, you know, on ESPN or whatever, via you know, kind of a satellite distribution link in between. And like 20 seconds later, she sees a touchdown on TV. As a viewer, and unless I'm betting, the viewers in Oregon are completely oblivious to that delay because they're getting coherent production. And so you can delay when that production happens as long as production crew has a good experience, so long as you're not going right back to the stadium. But that's where 5G comes in, because if 5G and data centers that are close to if they're in those pops, then my equipment's close enough where I can go back to the stadium. I can do that piece of it. I have other options for IFB, right? So those, because that's also in audio, that's a feedback loop. So yeah, 5G could help from that sense.
All right, any other questions for Mike? Well, thank you so much. I really appreciate it. That was awesome.
Yeah, great presentation.
Thank you. Opportunity. Thank you.
Before we go, I do want to hand it over to Patty so she can discuss next month's meeting.
Hi, Mike, that was fantastic. That was a really good presentation. And it sort of feeds into our next month's meeting, because LinkedIn, the chief architect of the media center at LinkedIn is our speaker next month, Gary Schneider. I think you know him. He's going to talk about...
Familiar. Hi, Gary.
Yeah, he's on the meeting. Yeah, he's here. But he's going to talk about how they are leveraging today the cloud technology, and then what their vision for the future is. And I think that a lot of us engineers kind of want to know what they want, what the customers want. So I think that'll be very, very interesting. So thank you, Gary, for joining our meeting tonight. I hope you join them all. And,
yeah, thank you.
Yeah.
Thank you, Mike.
You're welcome, and send me the invite for that one. I'd like, definitely want to tune in.
Yeah, I think it'll be really interesting. It's everything that you talked about today in practical use of what's going on today, and then also, the vision of what we want to do with it tomorrow. So how can we keep going with this stuff? So I think that'll be a really interesting meeting. So thank you very much, Mike. That was really interesting.
Well, thank you, and it's great to be on with so many people I know, so many good friends. So thank you.
Yes, and that meeting next month, it's going to be February 17th at 6:30. So I believe that's the third Wednesday, like usual, but we'll send out an invite. If you are not on our email list, be sure to reach out, and Mona will put you on the list. Also, if you are interested in becoming like a SMPTE manager or an officer, reach out to one of the current managers. We are having elections coming up, and we would love to have you join. So I hope the rest of you have a very good night. Stay healthy, and we will see you next time. Thanks.
Thank you.